video, we're gonna talk about the trigonometric ratios of 35 at 30 degree, 45 degree, and 60 degree angles. So these are our learning target. First, I can identify the trigonometric ratios of 30 degree, 45 degree, and 60 degree. I can apply the trigonometric ratio to find the missing side lengths and angle measures of a special right triangles. And I can solve problems involving trigonometric ratios of 30 degree, 45 degree, and 60 degree. So when we say special right triangle, there are two types of special right triangle. First is the 45 degree to 45 degree to 90 degree. And the second is the 30 degree, 60 degree to 90 degree. Okay, those are the two types of special right triangle. So now let's talk about the first type of special right triangle, which is the 45 degree to 45 degree to 90 degree. Like for example, this is our right triangle. So the measure of this angle is 90, and this angle is 45 degree, and another angle is 45 degree. So in a 45 degree to 45 degree to 90 degree, the length of the hypotenuse is square root of 2 times the length of each leg. So let's say that our leg is x, another leg is x. So based on the properties of this special right triangle, the length of your hypotenuse is square root of 2 times the length of each leg. So if the length of our leg is x, we multiply the x into square root of 2 so that we can get the length of our hypotenuse. So that is now the length of our hypotenuse. Next, another example of let's have an example of 45 to 90 degree. Okay, let's draw again another right triangle. So the 45 and 45, and this is 90. Okay, let's say that the length of each leg is 1, and our hypotenuse, like what I said, the length of our hypotenuse is square root of 2 times the length of each leg. So the length of our leg is 1. We multiplied it by square root of 2. Therefore, our hypotenuse is square root of 2. Okay. So the length of the side opposite to 45 degree is 1. Let's say if this is our 45 degree. So the length of angle C, or the opposite side of the length of angle C, is 1. And the length of the side adjacent to 45 degree or angle C is still 1. So the length of the hypotenuse is square root of 2. So the following are the sine, cosine, and tangent ratios of 45 degree. So let's talk first, or let's try to solve the sine of 45 degree. So based on our formula, the sine is opposite over hypotenuse. So the opposite to 45 degree over hypotenuse. So the opposite to 45 degree or angle C is 1 over its hypotenuse, which is square root of 2. And then, remember that in fraction, there is no radical involved in denominator. So we can simplify that 1 over square root of 2, multiplied it by square root of 2 over square root of 2. So 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is square root of 4, because 2 times 2 is 4. Now simplify square root of 2 over the square root of 4 is 2. So therefore, the sine of 45 degree is square root of 2 over 2. How about the cosine of 45 degree? So in solving the cosine, the formula is adjacent to 45 degree over hypotenuse. So our adjacent to angle C is 1. And our hypotenuse is still square root of 2. Again, the same process. Since the radical is in denominator, so 1 square root of 2 times square root of 2 over square root of 2 is equal to, multiply the numerator to numerator. So 1 times square root of 2 is square root of 2 over 2 times 2 is 4, and the square root of 4 is 2. Therefore, this is now the cosine of 45 degree, square root of 2 over 2. Next, the tangent. So what is the tangent of 45 degree? Based again on angle C. So the tangent, the formula to solve the tangent is opposite over adjacent. So what is the value of our opposite, or the opposite of 45 degree is 1. And the adjacent is 1. So 1 over 1, it is 1. So that is the tangent of 45 degree. Now let's talk about the trigonometric ratio of 30 degree. In a 30 degree to 60 degree to 90 degree triangle with a side opposite to 30 degree, measuring 1, the length of the side of adjacent of 30 degree is square root of 3. So where is the adjacent of 30 degree? So this is the adjacent of 30 degrees. So the measure of that is square root of 3. And the length of the hypotenuse is 2. So this is the hypotenuse. So that is 2. And the opposite of 30, this is the opposite of 30 degree, is 1. So the sine, cosine, and tangent of 30 degrees are as follow. First, the sine of 30 degree. Again, the formula to solve for the sine is opposite over hypotenuse. So based on the given triangle, we are looking for the opposite of 30 degrees. So this is the opposite of 30 degree, and the length of that is 1. And the hypotenuse is 2. Hypotenuse means the longest side. Therefore, the sine of 30 degree is 1/2. How about the cosine of 30 degree? So the cosine of 30 degree is adjacent over hypotenuse. So our adjacent is square root of 3 and our hypotenuse is 2. Therefore, that is now the cosine of 30 degree. And the tangent of 30 degree. Again, the tangent is opposite over adjacent. So our opposite is 1 and our adjacent is square root of 3. Again, there is a radical involved in denominator, so we are going to simplify that. We multiplied it by square root of 3 over square root of 3. So 1 times square root of 3 is square root of 3, and square root of 3 times square root of 3 is 3 times 3. So we have square root of 3 over square root of 9, because 3 times 3 is 9. And square root of 3 over the square root of 9 is 3. Therefore, this is now the tangent of 30-degree angle. So now let's talk about the trigonometric ratio of 60-degree. In 30-degree to 60-degree to 90-degree triangle with a side adjacent to 60-degree measuring 1. So this is our 60-degree, and this is its adjacent side. Therefore, the length of that is 1. And the length of the side opposite to 60-degree is square root of 3. So this is the opposite side of the angle 60-degree with a length of square root of 3. And the length of the hypotenuse is 2. Okay, so this is our hypotenuse, or the longest side. Now, the sine, cosine, and tangent of 60-degree are as follows. Okay, first, the sine of 60-degree. Again, sine is opposite over hypotenuse. So the length of our opposite based on 60-degree is square root of 3. And our hypotenuse is 2. Therefore, that is the sine of 60-degree. Next, for the cosine of 60-degree, the cosine is adjacent over hypotenuse. So our adjacent of 60-degree is 1, and our hypotenuse is square root of 2. So therefore, the cosine of 60-degree is 2. And the tangent of 60-degree. So tangent is opposite over adjacent. Our opposite is square root of 3, and our adjacent is 1. We can simplify that. It becomes square root of 3. That is the sine, cosine, and tangent of 60-degree. So now we are going to solve problems involving trigonometric ratio of 30 degree, 60 degree, and 45 degree. So like for example, we have a triangle here, the triangle PQR. And the measure of its angle Q is 60 degree. And the length of the opposite to 60 degree is 15. So we are going to solve the QR. So to solve for the QR, this is now the solution. Tangent 60 degree is equal to 15 over QR, because look, we are looking for the measure of the QR, or the length of the missing sides. So we are looking for the QR. So QR is equal to 15 over tangent 60 degree. Next, our QR is equal to 15 over square root of 3. Since there's a radical involved in denominator, multiplied it by square root of 3 over square root of 3. So our QR is equal to 15 square root of 3 over 3. And try to simplify that. Since 15 is divisible by 3, so how many 3 are there in 15? We have 5 square root of 3. Therefore, that's the value of our QR, 5 square root of 3. Another example, if we have a triangle ABG and the measure of angle B is 45 degree and the length of AG is 12. So what is the measure of the length of BG or the side BG? So sine 45 degree is equal to 12 over BG. So BG is equal to 12 over sine 45 degree. Next, 12. So what's the value of sine 45 degree? It is square root of 2 over 2. Next, 12 times 2 square root of 2. Get the reciprocal of our denominator. So 2 times 12 is 24 over square root of 2. Again, there's a radical involved in the denominator, so we are going to multiply this into square root of 2 over square root of 2. So we have 24 square root of 2 over 2. Since 24 is divisible by 2, so 24 divided by 2 is 12 square root of 2. Therefore, the length of your BG is 12 square root of 2. Another special right angle triangle, we have the KHJ. So the measure of your angle J is 30 degree and the length of your side JH is 10. So we are going to find the missing side or the missing length of the side KJ. Since we are looking for the opposite or the adjacent of the 30 degree. So cosine 30 degree is equal to KJ over JH. So cosine of 30 degree is equal to our KJ over our JH is 10. Then we are looking for the length of this. So we have KJ is equal to 10 times cosine 30 degree. You multiply this into this to solve for the KJ. So our KJ is 10 and cosine 30 degree is square root of 3 over 2. So 10 times square root of 3 is 10 square root of 3 over 2. Then 10 divided by 2 is 5 square root of 3. So that's how to solve the special right triangles in finding the exact value of the missing side lengths and the trigonometric ratios of 30 degree, 45 degree, and 60 degree. Do not forget to like, share, comment, and subscribe on my YouTube channel for more videos about mathematics.